Okay, so Leetcode practice time. In this video, there are two goals. The first one is to find a solution for this specific problem and also do some coding. And the second one is to see how to solve this problem properly by following the interview process. So let's get started. So remember, the first step is always to try to understand what the problem is, what it is asking us to do. If there's anything unclear, please bring up the clarification questions, and at the same time think about some edge cases which we need to pay special attention to. So let's see. This one is graph bipartite. So given an undirected graph, return true if and only if it is bipartite. So recall that a graph is bipartite if we can split its set of nodes into two independent subsets A and B, such that every edge in the graph has one node in A and another node in B. Alright? So the graph is given in the following form. Graph I is a list of the index j for which the edge between node I and j exists. Okay, so each node is an integer between 0 to graph.length -1, and there are no self edges or parallel edges. Alright. Okay, so graph I doesn't contain I and it doesn't contain element twice. Alright, so I think it has helped us clarify the edge cases, like self redirecting and also duplicate edges. Okay, let's see the constraints that, okay, so no self-directing, and also graph ij will be between 0 to the number of the nodes. Okay, and all the values are unique in graph I. Graph is guaranteed to be undirected. Okay, so I is equal smaller or equal to, okay, so they're between 1 to 100 nodes. This means between 1 to 100 nodes, and each node has 0 or has 0 to 99 edges. Okay, yeah, I think we are pretty clear about this. There isn't too much things we need to clarify at this moment, because based on the constraints, it says all the graph. First of all, the graph is valid, and also there's no self-directing edges, something like that, and also there's no duplicate edges. So let's see. So for example 1, so 0 to 13, 1 to 02, and 2 to 13, and this one means 3 to 02. Okay, so it is true because we can separate it into two things, which is 0 and 2 in the group and 1 and 3 in the group. Yeah, so I think what we could do is we could use a DFS on top of this problem. So first of all, we start with some nodes, and let's say we mark it at red and black. So first of all, let's say we start at node 0, we mark it as red, and then all the adjacent nodes for 0 should be black. So we mark 1 and 3 as black, and then we further extend to 2, so we mark the 2 as a red. So after we mark everything and we don't see any conflict, then it means we can say that it's a bipartite graph. So that's pretty much the solution. The solution is DFS, and let's see how much time it's gonna take. So it's gonna take, I would say we need to visit all. So for each node, we need to visit all of its adjacent nodes. And if it is like a sparse graph, like there isn't too much edges, then we still definitely need to visit all of its nodes. So I would say the worst case would be let's say there are n number of the nodes and there are e number of edges, so it would be O(n plus e) for the worst case. So for the worst case regarding the runtime, so after we find the solution, the next part is to do some coding. So the coding part, we care about the correctness, the readability, and of course the speed. So let's get started. So okay, so first of all, we are going to, let's say we define the color array as new int graph.length. So the color array will, at the very beginning, it will be initialized as all 0, and we are going to try to color the different nodes into either 1 or 2. So at the very beginning, none of the node is colored, so we are going to say, okay, iterate through every node, graph.length plus I. Let's say we define a function, let's say is valid color. Let's say we define something, put a placeholder here. So if it is valid color, if it is not valid color, then we are going to return false. Otherwise, we are going to return true finally. So I would say we could do some filter thing here. So if color is not equal, color I is not equal to 0, it means we have already visited this this node and the node before, so we don't need to visit it again. So we just need to continue here. Otherwise, we will visit this node by calling the valid color function, which is a helper function we are going to define later on. So let's say we are going to define a helper function is valid. So we are, first of all, we need to say which node we are trying to visit. So it is a node, and the second thing is what color it is going to be given. So let's say current color, or maybe just node color. And we are going to pass the color array here, and also we are going to pass the graph here. So we are going to say, okay, this one is I, and this is, we can give it either 1 or 2. So 1 is just fine. And then we pass the color array and we pass the graph here. Okay, so let's see. If the current node somehow, if the current node is colored, if the color node is not equal to 0, and the current node color is not equal to the node color we are going to give the node is not equal to the current color it has, then we are going to return a false for it. Otherwise, if it means it is either not colored, or it is like the current node color we are trying to give in has already matched the color of it before. So let's say if node color already matches color node, then we just need to return true for this one, because this is a valid node for when we try to color it. Otherwise, it means this the node hasn't been colored, so we are going to set the node, the color of the node. Okay, and then we will try to visit all of its neighbors. So let's say neighbor by going through graph node. Okay, so it's all of its neighbors. So if not is valid, so this is a neighbor and this is a node color. Let's say it is 3 minus the node color, because we are going to try to color it as either 1 or 2. And then it is a node color. What is that? So color, yeah, this is just color array and the graph. So if it's not valid, then we return the false for it. Otherwise, we just return true. Okay, so since then we have finished most of the code. Let's see. The next part is about testing. We will go through this piece of code by manually and explain how this code is going to work to the interviewer, and then we will try to come up with different test cases to try to increase the test coverage. So let's say is bipartite. So first of all, we are going to have a color array, and then you go through every node. If the current color of the node is, if the node has been colored, then we just continue. Otherwise, we call this DFS function on top of it. So let's say at the very beginning we call valid color. So we call valid color 0, 1, and the color graph and the graph, the color and the graph. So currently auto color is 0, 0, 0, and 0. And then we see that the node hasn't been ever colored. So we are going to color it as color 0 as, so we are going to give it a 1 as a color for node 0. And then we are going to visit all of his children, all of his adjacent nodes, which are 1 and 3. So we are going to say assign 1 and 3 both as 2 when we call the valid color on top of it, on top of 1 and 3, given 2 and 2. So 1 and 3 will be 2, color 2 and 2. And then for number 1, it is going to call 0, and it is going to the adjacent nodes are 0 and 2. So 0 has a valid color, 2 hasn't been colored, so it is, we are going to call the 2, give it a 1. So currently it is 1 here. Yeah, so and after everything returns, I think it should be a true case. Yeah, so let's give it a try. Is valid. Okay, so it's accepted. Okay, so now I think we should be good about this question. And regarding the task case setup, definitely set up one task case that can be bipartite, is bipartite graph, and another one that it's not. Maybe just give example 1 and 2 is enough. So that's it for this coding question. If you have any question about it, please leave some comments below. And if you feel it helpful, please give me a thumb up, and I'll see you next time. Thanks for watching.